All right, so let's continue with chapter 5 and just a little refresh here, looking at our three-stage memory model with the sensory register and auditory information. What are those items called here in the sensory register? You remember echoes? Yep. How about visual information? Yeah, right, they're icons. So echoes and icons, and we can also hold touch information here briefly. Anyways, if we pay attention to this information, it goes into short-term memory, and then we can process it, encode it, hopefully into long-term memory, and then later on retrieve it and remember it. And then below here we just saw the characteristics of short-term memory, including its three major limitations. Limitation in the number of things we can store in there, 7 plus or minus 2. Limitation in the time that we can hold information there without having to consciously and effortfully maintain it. And the fact that memories are easily disrupted is another major limitation. So let's take a look at the duration now of short-term memory and just that fact that, okay, so things won't last there for forever without conscious processing. So to study this, subjects were presented with just 3 letters. So this is a nonsense trigram. Nonsense because it doesn't spell out a word or anything. And trigram, just 3 letters, right? And so as an example, TXZ. So after being given these 3 letters, TXZ, the participants were given a number, 796 for example, and they were asked to count backwards in threes. So the purpose of this is to make them concentrate and use up their short-term memory so they couldn't keep rehearsing TXZ, 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 because you can't do that while you're doing mental math. So they're given the number 796, and then they have to keep subtracting 3. So 796, 793, 790, 787, 784, and so on, right? So you just keep subtracting by 3, and that, if you do that for a little bit, you realize, while you're doing that, you really can't keep remembering TXZ. After 3 seconds, 54% of the participants were able to recall the letters, but after 18 seconds, only 6% were able to recall. So this suggests that we do not remember stuff very well if it's not rehearsed in, short-term memory. If it's just there and then our mind is taken off of it, it is gone. It's basically gone. So yeah, so we don't keep things there very long at all without effortful processing, without rehearsal or elaboration. So chunking is another thing that we can do, and this is useful also for dealing with the limitations of short-term memory. And what we do with chunking is we group things together. We kind of create a singular item instead of multiple items. So we do it all the time with speech, because what is speech? It's putting together these different speech sounds, these phonemes. So the word battery has 3 phonemes, ba-ter-e, but we don't think of it as 3 sounds, we think of it as 1 word. We take 3 different sounds, we remember it though as 1 word. We have chunked those 3 sounds into a single unit, into 1 word. Your textbook also has an example using this number. The number is long enough that it is greater than 7. It's going to be difficult for people to remember, but a way to get around that is you break it up into these 3 different chunks. So 1492 could be a year, a historical year. 90210, yeah, right, a zip code, the TV show. And then 714, the area code, Orange County, I think, right? So this large string of numbers can be broken down into 3 familiar things, and that's a great example of chunking. Likewise, these 3 letters that don't spell out a word can just be put together as Joy hug cat, right? And then you can even picture Joy hugging her cat, and that helps chunk it into less information in short-term memory. And so remember, which limitation of short-term memory does chunking help us deal with? Yeah, right, the storage capacity. So storage capacity is dealt with through chunking. So let's take a look at why people forget. This is something that I think a lot of us just assume works differently than it really does. So there are 2 possibilities. One is that the information just decays over time, and I think this is probably the most popular interpretation, and the assumption that probably most people have is that if I can't remember something, that information, just sort of decayed. It's no longer available to me. It's not in my brain anymore. I just don't remember it. It's a memory fades over time. So I think that's the idea of decay. The other possibility is that some other information is interfering with our ability to recall or to retrieve this information. We can just refer to that as interference. Turns out that interference is really the most common reason for forgetting. And there are two types of interference. One is retroactive, and so obviously the word retro was kind of thinking something, in the past. And so with retroactive interference, new information is going back and interfering in a sense with old information that's already been stored. So the interference is going back or retroactively. And an example would be that you can't remember your old phone number because maybe your new number is kind of similar. And so the new number interferes with your ability to remember the old number. So that's an example of retroactive interference. Proactive interference is the other possibility. And so this is where older information or previously learned information somehow interferes with new information you're trying to remember. So as a common example, you might, give, like, just in a moment without really thinking about it, use the wrong name to refer to someone. So you might call your new boyfriend by your old boyfriend's name. Not wise, I don't recommend it, but it happens. And that would be an example of proactive interference. So that's an example, of how these things work, that some information that you learned in the past is making it difficult to remember something new. So I'm going to give you a little example, something that happened to me. So I had the opportunity to go to Brazil for a few weeks, and I speak Spanish. I already speak Spanish and Portuguese is pretty similar, and I studied Portuguese before I went, and once I was there I really kind of did my best to speak as much as possible, and Brazilians are so nice and friendly. They put up with my bad pronunciation and stuff. But what was kind of funny was what happened when I returned, and I remember trying to speak Spanish with my relatives and I couldn't. The only words that would come out were Portuguese words at this point. The Portuguese that I learned in Brazil was interfering with my ability to speak Spanish, right? A language that I'd spoken since I was a kid. So which of those two examples of interference is what happened to me? Is it retroactive interference or proactive interference? So because I couldn't remember how to speak my old language in a sense, we can think of that as an example of retroactive interference, huh? So anyways, I just want to give you a little example of those two. And again, probably the big picture here is that we tend not to forget because of decay or because the memory trace, sort of fades with time. Most research supports that it's really more a matter of interference. And then we can also look at what we know about how we search for information in short-term memory. This is really kind of surprising to me. So here on the bottom, we have the set size, right? And you can see that goes from 1 through 5. So a set of size of 1 is 1 item, set size of 2 is 2 items, right? So 2, 3, 4, 5. So we can just think of these as 1, 2, 3, 4, or 5 words. And response time is how many milliseconds it takes a person to say if a new word, for example, is one of the original words. So if they're only given one word, say lemon, then it only takes about 400 milliseconds to report that they, yes, saw or read the word lemon earlier because they only had one word to deal with. And if you increase the number of words on a list, for example, you can see at the time it takes them to remember goes up just a little bit, right? To a little bit over 500, it looks like. So, okay, so that's kind of interesting. It means that we can search for information in short-term memory pretty quickly. But how come there are two lines here? This is where it gets interesting. The blue line is how long it takes people to search when, say, the list of words is lemon, apple, orange, grape, banana. But the question is, was watermelon one of the words, or was peach one of the words? And it turns out that if watermelon or peach was not one of those words, that we take basically the same amount of time to determine that a word was not on the list as it does to determine that a word was on the list. So positive versus negative. A positive is that the word is on the list, so maybe lemon. A negative is that the word is not on the list, maybe peach. This part's a little surprising because you would think if you're looking for lemon, more often than not, lemon might be the second item you look for, or third or fourth. It might be, earlier on your search, and you might come to it and then stop your search and say, hey, okay, yes, I do remember, reading the word lemon. And then if the word was peach, that we wouldn't know that peach wasn't on that list until we went through our entire list. And so what this is showing is that, number one, people do go through the entire list all the time, even when the word we're searching for is on the list. And so because of that, it looks like we do what's called a serial exhaustive search through short-term memory. Serial means that we just go in order looking through the items. Exhaustive means we go through the entire list. We go through all the items. We don't stop at some point when we find the correct answer. We keep going to the end, probably because we are super quick and efficient in searching our short-term memory. So we don't stop once we find the item. So serial exhaustive search.